So as we move forward into solving linear equations are kind of the backbone to a lot of math and a lot of problem solving. So in the real world, your goal is to solve a problem. One of the strategies is actually what we call creating an equation, or there may be a formula that you can use that you have to solve by putting information into an equation. But also sometimes you may have to manipulate the equation. So we want to go through an exercise of just solving some basic, what we call linear equations. So again, the goal to solving any equation, and in particular here, a linear equation, is to find the value of the variable. So remember, the variable is an unknown that makes, in this case, we want to make the equation true. So a lot of times you hear the phrase solve for x, or in our assignments, you may have other variables besides x. So to find the solution, what that means is the value of x, if you will, is going to make both sides equal. So if we look at this equation, notice how we have x is going to represent some number, but you got to add 3 to it, and you have to get 7. So if you can think of a number that makes the left side equal to the right side, that's called the solution. So we should be able to pick up on that. 4 plus 3 is equal to 7. Oops, that's not a 7. So therefore, x would equal 7. And sometimes they write this as a solution set. So it's a solution set, you have the set notation. And if you have the set notation, the only thing you put inside the set notation is the solution. So 7 would be the solution. So don't go x equals 7 in your homework. This would be wrong notation in your homework. You just want to put the solution, which is a 7. If you type x equals 7 in, it'll be wrong. So that's where practicing your homework will help you out so you don't make that mistake on your test. Now, for linear equations, what makes a linear equation is the degree of the term. So in the variable, in the problem, if the degree of the variable is 1, then we call that a linear equation. Now, the degree is the exponent of the variable. So again, notice that if there is a term, if a term is just a number, its degree is 0. But notice how in our equation, x plus 3 is equal to 7. Notice that the left side has two terms. X and 3 are the two terms on the left side. X has an exponent of 1. Since 3 does not have an x, it's considered a degree 0. So numbers just have degree zeros. And notice how 7 is just a number, so it's a degree 0. So the highest degree term comes from the x. And since it's a degree 1 equations are called linear. So again, if the highest degree is 1, the equation is described as linear. Now, important here is a linear equation cannot have more than one solution. So if you find one answer, there cannot be more than one answer if we're solving a degree 1 or a linear equation. So keep that in mind. So the other thing we pick up on with equations is this concept of keeping the equation balanced. So keep in mind, an equation is like those balance scales, if you will. I can't draw them really well, but you have this side here and this side here. You want them to be level, balanced. What we don't want is we don't want this side high and this side low. So if the scale looks like this is unbalanced. We don't want that. So if we have an equal sign means the left side and right side represent the same value. It's balanced. What we want to do is keep the equation balanced. So one of the things we pick up on is you're allowed to perform operations, but if you perform an operation on one side of the equation, you must perform that exact same operation on the other side of the equation. So whatever you do to one side, you must do to the other side to keep it balanced. So some things you can do is you can add the same number to both sides. You can subtract the same number on both sides. You can multiply both sides by the same number, and you can divide both sides by the same number. But there is an exception. Division by zero is undefined. So you cannot divide by zero. So in our course, there's probably not going to be a reason to see division by zero. But again, division by zero, you can't get an answer. So just keep in mind, if I give you, say, 10 divided by 2, the question is how many twos, if you will, can give me 10? Well, 5 times 2 would give me 10, so I need 5 twos to get a 10. So that has a solution. But if I give you 10 divided by 0, the question is how many zeros, if you will, try to do that again, make that multiplication symbol look a little bit better. So how many zeros can you get to 10? So if you keep adding 0, you're never going to get to 10. So what I pick up on is division by 0 is undefined. And also if you pick up on when you multiply by 0, this side is always 0, and 0 is never going to equal 10. So it's never going to be balanced. So it's not going to be true. So division by 0 is something we want to avoid. So keep in mind in our problem, if we see 0 in the denominator, that's no good. That's going to be what we call undefined. So we cannot have 0 in the denominator because we can't figure out how many zeros get into 10. So we have to pick up on that as well. So the other thing we got going on is simplifying both sides. So in solving equations, we want to simplify both sides first. So simplifying is an important piece to solving linear equations. So simplifying means we have to combine like terms. That may involve the distribution property, which remember, distributing a lot of times what's that doing is it's removing parentheses. So that allows us to kind of keep moving forward in the problem. So if I look at this example here, 2x plus 3 plus x equals 9. Notice that the left-hand side can be simplified because we have like terms. This 2x can be added to this 1x, if you will. So 2x's plus another x would be 3x. So this would turn into 3x plus 3 is equal to 9. So one of the things we got to do in solving equations is we have to simplify each side first before we start trying to isolate the variable x. So the key thing is we want to get the variable on the same side of the equation. So all the variable terms need to be on one side of the equation if we're trying to solve it algebraically. So to do this, we use addition or subtraction to move the variable to the same side of the equation. A lot of times here, I refer to this as pick on the little guy. That's not quite how you spell little. So pick on the little guy. So this is really not correct vocabulary. It's just a kind of a phrase I use a lot of times in my thinking. So notice how this is an equation because there's an equal sign. And what I want to do is find the value of x that makes each side equal. I could guess and check and see if I could just find it by just randomly guessing, you know. But also what I can do mathematically is I can try to get x on one side of the equation. So what I'm seeing is 3x is on one side and x is on the other side. So what I want to do is zero out this x over here. To zero out that x, I need a negative x or subtract an x. And if I put a negative x there or subtracting x, to keep it balanced, I got to subtract an x over here. So this turns the equation into 3x take away an x would actually be 2x's. So this turns into 2x plus 4 is equal to 10. So that's another strategy we need to do is in solving our equations, if the variable is on both sides of the equation, we need to get the variable on one side. So usually I pick on the little guy. So between a 3x and an x, I consider x smaller. So to get rid of it, I use its opposite. So I subtract an x. But to do that, I have to balance the equation by subtracting an x on the other side. So this creates a new equation that's still true because it's still balanced. It's a different equation, but it's a balanced equation, and that's the key here. So it may be different, but it's still a true statement. The other thing we want to do is move the constant terms to their side of the equation. So the numbers or constants we want to move to their side. So really what we want to do is also move it to the opposite side of the variable. So notice how we have 2x plus 4 is equal to 10. I want to get the numbers away from the variable side. So I want to pick on this 4 because I want to move it away from the variable. So again, we want to be on the opposite side of the variable. So to get rid of this positive 4, we can subtract a 4 here as long as we subtract a 4 here. And this gives us then this 2x is equal to 6. So I do have a new equation. And notice how by doing this, the equation starts to look really simple because now you can already see the answer. 2 times what number is going to give you 6? You can probably say, hey, wait a minute. I can see the answer now. 3 would be the solution. So that's what's key to this. If I can start to get these equations looking a little bit more manageable, I can see the answer in that situation. So the last thing is we want to make the coefficient of the variable 1. So essentially, we're going to multiply or divide to do that. So right now, notice how our variable is on one side of the equation, but what we want to do is get rid of its coefficient. So to make this coefficient a 1, we know that if you divide a number by itself, it turns into a 1. So if I divide that side by 2, I can divide that side by 2. So notice that these 2's will divide out and turn into a 1. So this turns into 1x equals then 3. But 1x is simply x. We don't need the coefficient in that situation. It's understood to be 1, so we don't have to put the 1 there. So traditionally, x has a coefficient of 1. So once you get to this spot here, 1x is simply x. Notice how that is now our solution. Our solution set would be then 3. 3 would make this problem true. The last thing to do is substitute your answer back into the original equation and verify if it works. There's also some situations where there is no solution or infinitely many solutions. If you look at this example here, notice how we have this x plus 2 equals x plus 5. Notice that regardless of what the variable is, this side is always going to be 3 smaller than this side. Now remember, one of our strategies was, hey, the variable is on different sides of the equation. Let's get it on the same side of the equation. So notice how if I lose x here, I have to lose an x here. But notice how this turns into 2. Let me go back to that other color. So notice how this turns into 2 equals 5. Will 2 ever equal 5? No, this is untrue. So 2 will never equal 5. This is a false statement, not a true statement. So when we get a false statement, this tells me that it doesn't matter what x is, this equation is never going to be balanced. It's always going to be unbalanced. The right side is always going to be a little bit heavier than the left side because you're adding 5 over here, while here you're only adding 2 to x. So this is going to always be 3 more over here. So it's going to be slightly heavier. So from a scale perspective, this is a bad case all to begin with because the right-hand side is already heavier. So it's going to be out of balance and it can never be balanced. So we have that going on. Sometimes we find that there's going to be infinitely many solutions. So if I look at this equation, I have 2x plus 4. Notice over here, I could multiply the 2 through the parentheses. So I have 2x plus 4 over here. And to remove the parentheses, I can distribute the 2 through the parentheses. And that's going to be this 2x plus this 4. Notice how the left side and the right side are equal. So that tells me that it doesn't matter what x is, each side is going to always be balanced. Now, again, if you go ahead and get the x on the same side of the equation, if you so happen to decide to subtract 2x on both sides to get the variable on one side, you again realize that something weird happens here. The variable zeroes out of the problem and you just have 4 equals 4. But also that doesn't 4 always equal 4? So what that's telling you is it doesn't matter what x is, it will always work. So this is going to be, in this situation, the set of all real numbers. And the set of all real numbers means we have infinitely many solutions because there are infinitely many real numbers. So again, to summarize, when we are solving linear equations, this is kind of your checklist. So this is where we basically are. You want to simplify both sides. So that's like combining like terms, distributive property, removing parentheses. Move the variable to one side. Again, that's where I talk about pick on the little guy. Then you start wanting to get the variable by itself. So then you move the numbers to one side, isolating the variable. And then the last thing you want to do is get rid of the coefficient of the variable. And then that variable should be isolated. And then it's always a good idea to check your answer. So again, we have clear definition of linear equations. So again, remember, this strategy only works for degree 1 equations. So what we're talking about are linear equations, degree 1 equations. So this is kind of our overview of that. So again, you can pause this and take down these notes if you want to. So in my next video, I'm going to apply these strategies.